Welcome to CREmedical's instructional video. In this video, we'll cover how to set up the T-leads and T-interface 20 with an amplifier in order to record brain signals. This video has 5 parts. In part 1, we will provide an overview of the T-leads and the T-interface 20. In part 2, we will cover preparing and placing the T-leads. In part 3, we will show how to connect the T-leads, the T-interface 20, and an amplifier. In part 4, we will show an example recording of brain signals and discuss signal quality. In part 5, we will discuss important notes such as care of the T-leads in the T-interface 20 and charging the T-interface 20. Let's begin with part 1, overview of T-leads and T-interface 20. This is a picture of our T-lead, which is a lead made up of a TCRE, or tripolar concentric ring electrode. It is the same size as a conventional disc electrode, however it has an outer ring, a middle ring, and a central disc. We take the differences between the outer ring and the central disc and between the middle ring and the central disc. This design automatically cancels noise and provides the Laplacian, which also increases the spatial resolution. This design also reduces mutual information between electrodes. We call the signals recorded this way tEEG signals. If you record from only the outer ring of the T-lead, the signals recorded emulate conventional eEEG signals recorded with a disc electrode. We call these outer ring signals eEEG. Thus, with each T-lead, you will obtain 2 output signals, one high-fidelity tEEG signal and one conventional eEEG signal, or eEEG. This is a picture of a T-interface 20 unit. This is the front of the unit where we plug in the T-leads, and this is the back of the unit where we plug in the output cables. The T-interface 20 serves to configure the T-lead electrode elements, route, and preamplify the signals. The T-interface 20 was designed to be compatible with common eEEG amplifiers and software on the market. Its outputs have standard touch-proof connectors that mate with common eEEG amplifier headboxes. Part 2. Preparing and placing the T-leads. Prepare the subject's scalp as you normally would when placing conventional disc electrodes. We apply 2 to 3 millimeters thick of 1020 paste or Elifix on the TCRE prior to placing the T-lead on the scalp. Be careful not to press on the T-lead too much when you are applying to the scalp, or else you will eject the paste. When using multiple T-leads, we usually apply labels with tape at both ends of the leads. The labels allow us to map the location of the T-leads on the head to the input channel of the T-interface 20. Part 3. Connecting T-leads, the T-interface 20, and an amplifier. This is the front of the T-interface 20. It has 20 input channels, numbered from 1 to 10 and 11 to 20. Prior to plugging anything into the T-interface 20, turn the T-interface 20 on. Ensure the 2 green power lights are on. If one or both lights do not turn on, turn off the T-interface 20 immediately and call CREmedical customer support. We will now plug in 20 T-leads, starting with channel 1. Channel 1, Channel 2, Channel 3, Channel 4, Channel 5, Channel 6, Channel 7, Channel 8, Channel 9, Channel 10, Channel 11, Channel 12, Channel 13, Channel 14, Channel 15, Channel 16. If you are only using 16 channels for your recording, you can stop here. It is not necessary to plug in all 20 T-leads if you are using fewer channels. If you are using all 20 T-leads, let's continue. Channel 17, Channel 18, Channel 19, Channel 20. If you are using more than 20 T-leads, you can stack multiple T-interface 20 units. This is the back of the T-interface 20. There are 4 output connectors, as each T-interface output cable routes signals from 5 T leads between the interface and the amplifier. The output connectors are labeled with the corresponding channels: channels 1 through 5, channels 6 through 10, channels 11 through 15, and channels 16 through 20. Since we connected all 20 T leads in this demo, we will need to connect all 4 output cables. The colored wires on the output cables are the inputs to your amplifier. The output cables are interchangeable between output connectors on the T interface. This chart shows how the colored wires correspond to the output signals for each channel. Be sure to keep this chart nearby for quick reference. As mentioned earlier, there are 2 output signals for each channel, one for the tripolar signal, the tEEG, and one for the signal from the outer ring only, the emulated conventional EEG or eEEG signal. In this example, we are interested in acquiring the tEEG and eEEG signals from all 20 T leads. This means we need to connect all of the colored wires from each of the 4 output cables to the amplifier. If you are only using 16 T leads, you would connect all of the colored wires from the first 3 output cables and only the black and brown wires from the last output cable to the amplifier. In our example with 20 T leads, if you are only interested in acquiring the tEEG signals, you should only plug in the black, red, yellow, light blue, and gray wires. Similarly, if you are interested in only acquiring the eEEG signals, you should only plug in the brown, orange, violet, dark blue, and white wires. You can plug the T-interface output cables into any of the inputs to the amplifier in any order that you would like, but be sure to keep track of where each signal is going. In this example, we will follow a pattern of plugging in the tEEG signal followed by the eEEG signal for each sequential channel. In the first output cable, the black wire carries the tEEG signal from T-interface channel 1. We are plugging it into channel 1 on the amplifier. This is the brown wire carrying the eEEG signal from T-interface channel 1. We are plugging it into channel 2 on the amplifier. This is the red wire carrying the tEEG signal from T-interface channel 2. We are plugging it into channel 3 on the amplifier. This is the orange wire carrying the eEEG signal from T-interface channel 2. We are plugging it into channel 4 on the amplifier. This is the yellow wire carrying the tEEG signal from T-interface channel 3. We are plugging it into channel 5 on the amplifier. This is the violet wire carrying the eEEG signal from T-interface channel 3. We are plugging it into channel 6 on the amplifier. This is the light blue wire carrying the tEEG signal from T-interface channel 4. We are plugging it into channel 7 on the amplifier. This is the dark blue wire carrying the eEEG signal from T-interface channel 4. We are plugging it in to channel 8 on the amplifier. This is the gray wire carrying the tEEG signal from T-interface channel 5. We are plugging it in to channel 9 on the amplifier. This is the white wire carrying the eEEG signal from T-interface channel 5. We are plugging it into channel 10 on the amplifier. The second output cable carries signals from T-interface 20 channels 6 through 10. We continue our pattern of tEEG followed by eEEG. Channel 6 tEEG, Channel 6 eEEG, Channel 7 tEEG, Channel 7 eEEG, Channel 8 tEEG, Channel 8 eEEG, Channel 9 tEEG, Channel 9 eEEG, Channel 10 tEEG, Channel 10 eEEG. The third output cable carries signals from T-interface 20 channels 11 through 15. Channel 11 tEEG, Channel 11 eEEG, Channel 12 tEEG, Channel 12 eEEG, Channel 13 tEEG, Channel 13 eEEG, Channel 14 tEEG, Channel 14 eEEG, Channel 15 tEEG, Channel 15 eEEG. The last output cable carries signals from T-interface 20 channels 16 through 20. Channel 16 tEEG, Channel 16 eEEG, channel 17 tEEG, channel 17 eEEG, channel 18 tEEG, channel 18 eEEG, channel 19 tEEG, channel 19 eEEG, channel 20 tEEG, channel 20 eEEG. The green wire is the ground for the T-interface 20. Only one green wire from any one output cable needs to connect to the isolated ground of the amplifier. Note that you still need to plug in conventional disc electrodes to both amplifier ground and reference as in conventional eEEG recordings. If your amplifier only has one isolated ground connection, you will need to use a jumper in order to plug in both the T-interface green wire and the ground disc electrode. Prepare and place the ground and reference disc electrodes as you normally would. This completes the setup of 20 T leads in the T-interface 20. Part 4. Signal quality. These are the signals recorded from one T lead. The top trace is the tEEG signal, and the bottom trace is the eEEG signal. In order to properly visualize the signals, we have adjusted the sensitivity of the tEEG signal to 1500 microvolts peak to peak, and the sensitivity of the eEEG signal to 150 microvolts peak to peak. This is because the tEEG signal is amplified by the T-interface 20 approximately 10 times more than the eEEG signal. So we set the sensitivity on the tEEG signals to be about 10 times greater than that of the eEEG or regular eEG signals. Here, you can see clear signals with prominent alpha oscillations exhibited when the subject's eyes were closed. We typically record with a 60 Hz notch filter. Part 5. Important notes. Here we discuss the care of the T-leads in the T-interface 20, as well as specific instructions for charging the T-interface 20. To achieve the longest utility of the T-leads, it is important to wipe the 1020 or LFX from the TCRE and wash the T-leads in water immediately after each use. T-leads can then be cleaned with alcohol or the Clorox product noted here for sterilization. Do not boil T-leads for sterilization or soak the T-leads in acetone. Do not subject the T-leads to an autoclave. The T-interface 20 should be placed in a location where it is unlikely to get accidentally bumped or jostled by either the research participant or the research team. Do not subject the T-interface 20 to liquids. Do not use with any other components other than the original T-interface 20 components from CREmedical. The fully charged batteries of the T-interface 20 are expected to provide up to 24 hours of continuous use. Once any of the 4 red LEDs on the front of the T-interface turn on, you have approximately 30 minutes of use left with the T-interface 20. The charger input connector is located on the back of the T-interface 20 near the power switch. This is where you plug in the charger provided with the system. When the batteries are charging, the light on the charger will be red. When the batteries are fully charged, the light on the charger will turn green. The T-interface 20 power switch needs to be in the off position when the charger is connected in order to charge the batteries. Do not use any other charger than the charger provided for the T-interface 20. Other important notes include the fact that conventional disc electrodes are not compatible with the T-interface 20 and should be plugged directly into your amplifier as usual. The T-leads are the only electrodes authorized to be used with the T-interface 20. T-lead impedances should be below 10 kiloohms. Contact CREmedical directly for information about our impedance measuring equipment. Any necessary changes to the device must be performed by CREmedical only. Be sure to use the device according to the instruction manual. The instruction manual is included with your order on a USB stick. Lastly, and most importantly, the T-leads and T-interface 20 are not medical devices. They are intended for research purposes only. Thank you for watching. Feel free to visit our website, www.CREmedical.com, or email us at info@CREmedical.com with any questions.